So we're now going to talk about part 2 of this case study, and this is going to show off some other things, a little different from what we talked about before, but it's some of the same methods, but we're going to add in stuff like mapNotNull and doOnNext, just to do things a little differently when we create, divide, and display our BigFraction objects synchronously. So as usual, you can get this code in the ex1 project in the reactive Flux folder in my live lessons GitHub repository. So since we're in the second part of this example, we're going to take a look at the test fraction division error sync test method and the test mapNotNull test method. So let's take a look at test fraction division error sync first. As before, we're going to create a string builder that will be used to accumulate the results so we can print them out in one fell swoop. We're going to make ourselves a list of big fractions, just like we did before, with slightly different numerators and denominators here. But what we're going to do in this case is a little different. So we're going to convert that big fraction list into a flux. That's the same as before. However, now what we're going to do is we're going to have a map operator. And what this is going to do is it's going to divide each element in the stream by the constant 0 under some circumstances. So if the big fraction is equal to 2, and if you take a look up here, you can see that the third one in the list is going to be equal to 2 because its numerator is 100 and its denominator is 50, so that'll have the value 2. If the value equals 2 when it's reduced, we're going to divide it by 0, which of course is going to cause chaos and insanity, or more specifically, the arithmetic exception. Otherwise, we're going to divide it by 2. So the first several things in that list will work just fine, and so they're going to get displayed or logged by the doOnNext action operator. However, when we try to divide by 0, which will occur by the third element that's in this list / flux, in that case, we're going to get the arithmetic exception. That will be propagated up to the doOnError part, that action operator, and that will take the exception and it'll log the exception. So we'll see when we look at the results that this will tell you what happened. But up to that point, everything is copacetic. Down here, we subscribe. This part of the code is exactly the same as before. So we're going to have the normal cases handled here by printing the big fractions as mixed strings in the string builder. But we're going to have an error message when an exception comes up, and then we're going to display it that way. So you'll see things are a little bit more truncated this time. And just for kicks, let's go ahead and run this program, which will start up. It'll do the same thing it did last time. We're going to skip over the results from the first 3 test methods because we already looked at them earlier. And we're going to take a look at test fraction division error sync. And you can see here what happens is the first big fraction comes through just fine. We log it. Second big fraction comes through fine. We log it. And then at that point, the divide by 0 happens. So that is handled by the doOnError action operator, which says logging, divide by 0, fraction denominator is 0, which indeed is the problem. And then you can see also that through the subscribe call, the subscribe operator, that the error branch is what was triggered here. So it again, somewhat redundantly says divide by 0, fraction denominator is 0. And that is the error that's coming back from this call here, error.getMessage. So that's showing you how errors can be logged and processed using subscribe and the error arm of its parameter list. Let's take a look at the last of the methods here, which is test mapNotNull, which, as the name implies, is going to test the Flux mapNotNull operator using a synchronous Flux stream. Once again, we're going to have a somewhat contrived example just for kicks. We're going to use just to make ourselves a Flux. And in this particular case, we're going to have one of the values, the second value, be a numerator of 100 and a denominator of 10, which will reduce to the value 10. And we come down here, and we're going to use doOnNext to log these things. And then we're going to call mapNotNull. Remember, mapNotNull is going to suppress nulls. So in this case, if the big fraction equals 10, we're going to have it emit a null, which will be caught by mapNotNull, and therefore not emitted. It'll be ignored. And then we're going to omit the other one. So this will actually not trigger an error. It just won't log that particular value, or it won't print that particular value. And it won't go through mapNotNull. Other than that, the subscribe thing is the same. So let's go take a look at the run output. And what you'll see here, as you might expect, is that we end up with these results. And you'll notice that there is no null. So null was suppressed. It didn't go through mapNotNull at all. But there's no error, because it wasn't an error. It was just sort of eaten by mapNotNull. And you can also see at the very end that we completed 5 tests. And that, of course, is what's shown back over here, where at the end we printed out the number of tests that came back from async task barriers run task method. Why I point this out is later, when we start looking at the details of how async task barrier works, and we kind of dive under the hood and see its internals, we're going to see it keeps track of the number of tasks it called that completed successfully, and only those are included in the test count that's returned by it. And there's all kinds of really clever things that we use to make that work properly. So that's the end of case study ex1. This is really just to kind of get you acquainted with the very basic features of Project Reactor. In real life, there's a lot more interesting stuff. In real life, we would very rarely use all synchronous processing. Instead, we would be using asynchronous processing, and that's what we're going to start talking about in our next class.